I need to modify it because it's some typo error and maybe the content itself is actually not suitable or not related to what's inside week 11. And here are the updates. If you look at the second posting over here, I have the revised version and also annotated. The slide actually based on the annotation that I annotate during the class. And also, for example, that I showed on Tuesday, here are the annotated version where you can see that I've annotated some of the solution and also put some remarks over there. Right, for today's class or today's session, what we try to do is we try to have a tutorial, and I also uploaded the question for tutorial week 11. I hope you guys already downloaded this PDF file, because we have, I believe, about 3 questions inside the tutorial. Can have you downloaded?
Yes.
Okay. All right. Let's get into the question. If you download the file that I show you just now, the posting that I said just now, we have 3 questions for week 11, and the first question is about mesh analysis. Second one is source transformation. How do you solve current IO using source transformation? And also the final one is using superposition. This is sort of tutorial, let's say, example maybe, because I just asked you to do one question, maybe the rest of the question will be explained to you later on. And for this particular tutorial, as usual, I would like you guys to spend some time, maybe about 30 minutes, to do one question. And one of the students inside this session, hopefully I can find one student who volunteer to share his answer, and we compare it with what available in the solution. Okay, the question that you need to answer is question number, I think maybe number 2. And you normally for a question like this, you should spend about 20 to 30 minutes. 30 minutes is maximum, maybe 20 minutes should be enough. All right, please do question number 2. Now, I will give you guys about 30 minutes to answer it. And one of you, hopefully I can get a different person from the one that we have before this, to share his answer, and then we try to compare your answer. I think you can start now. Now it's 11:10 a.m. We will see again at 11:40 a.m. 30 minutes given to you. You can start now. Question number 2. Is there any problem so far?
No, sir, no problem.
Okay. And for those who just sign in or getting into this online session, please fill out the attendance form. You can check links in our chat room. Please download the file first, yeah, in e-learning, and then and start answering the question. All right, guys. Have you finished question number 2? Guys, can you hear me? Have you finished question number 2?
Not me.
Then who volunteer to share his or her answer? Who would like to volunteer, please? Can I have one name or one answer? Shall I pick? Will you please respond, someone?
I just need one more minute, 2 more minutes, sir.
Okay, Nasir. Okay, who would like to volunteer? Nasif, have you be a volunteer before this?
Yes, sir. Last time I was the volunteer.
Yeah. Okay. I think we should um, give the opportunity to other students.
Yes, sir.
Who would
Sure.
like to volunteer? Can I pick just one name from here?
Yes, you can pick.
Okay, Adam. Adam Kushairi, can you respond? Is Adam Kushairi here? I believe you're in this room. Adam, can you share your answer? Okay, just give what you have. Can you snap a photo of your answer and then uh, share it to me in WhatsApp group? Then I will present it here. Khairul Naim, why cannot? If you cannot do this, means that you will miss 10 marks from your assessment. Maybe if this is coming from the test, you will, you will miss that 10 marks lah. If this is from final, also it's around 10 marks. Okay, Adam, please share your answer in our WhatsApp group. Maybe later I can. We'll see. I can do it, to be honest. Yeah, it's okay, but I would like to see what's currently that you have, current answer that you have. Please share your answer, Adam. We are waiting for your answer. Okay, just for your information, this type of question is a typical question in your assessment. So you should expect that the question asked in the assessment is more or less should be like this. Okay, thank you, Adam. Okay, this is what we have from Adam. Okay. Right. Can you see the answer? It's halfway done, but Adam, basically you need to spend about 30 minutes to answer this one. Now it's already past 8 minutes, 38 minutes. It's okay. We will discuss the final answer now. All right, and if you look at the answer, maybe later on I will make this one bigger. All right, the for question number 2, actually we are trying to solve the answer or solve IO. Is it IO or VO? Let's see, what's the question? Solve IO and voltage VO, yeah. Using source transformation theorem. And if you look at the idea of solving this kind of circuit, here we have two elements connected in series, voltage, and the other one is a resistor. We also have these two also connected in series, where these two portion we can do a source transformation in order to simplify our circuit. And the next thing that we need to do is we try to find IO here, and from the IO we can get what is the value of our VO. So that's the idea of solving the question. And if you look at the circuit or components in the circuit, for the voltage, yes, it is given in a phasor, and current also given in phasor. Here we have the another voltage source given also in phasor. So we don't need to how to say it? We don't need to convert from a time domain into a frequency domain or phasor domain value. And if you look at other components like inductor and as well as the capacitor over here, it is presented in its original units. For inductor, it is in Henry, and for capacitor in Farad. Means that we need to do something, or we need to convert these elements or this component so that it will be represented in terms of its reactance value. In other words, we need to convert from farad to ohm value. Same goes to this inductor. And for inductor, normally this one will be converted into XL value, and this one will be converted into XC value. And to convert XL and XC, what you need is you need a frequency. So here in the question, if you read through the question, the frequency is given at 50 Hertz. So it's quite straightforward, but you need strategy how to solve it. As I mentioned just now, the first one, maybe you should convert this thing into its reactance value, and later on have a look at how we can do source transformation, or how we can use source transformation theorem in order to solve this problem. Okay, according to the solution that I have over here, maybe now, okay. And looking at the strategy that Adam used, yes, of course, he tried to convert or use source transformation to transform this into a parallel connected connection. Same goes to the one that we have over here. He also converted into what do you call it? Parallel connected connection between current and the elements of XL. And before that one, what he need to do is he need to he need to convert the capacitor as well as the inductor in its reactance value. The conversion that he used over here, he used for ZC, XC also can, ZC also can. It's presented by negative J, his answer is negative J 0.2. According to my calculation over here, it's negative J 0.59. It's more or less the same, and Adam, you should get 1 mark over here for ZC. And also for ZL, it's 6.3, and I got here is J 6.283, and more or less the same, means that this one is also correct. And it's good that you also show us, show the examiner how do you calculate this, all these values. It's coming from omega, where you use omega equals to 2 pi times 50, you get this value. Basically, if I would like to see an answer which is looks like this, because it's the information is there, so I can easily find how do the student calculate value of ZL and ZC. So in summary, these two should give Adam about 2 marks, and later on he's doing the conversion, but here the The calculation for the conversion is not available, but we'll see how do it looks like. So here he do redraw the simplified circuit. Suppose if I don't have any information about the calculation, the drawing or the simplified circuit should tells me what's the student plan to do. And here he got the current as 2 ampere, and my answer or my calculation over here is 2 with the angle of 0 degrees. So this is acceptable, and he should get 1 mark over here. And also for the one that on the right hand side for the current, he got 1.6 with the angle of negative 45. Here I got 1.592 angle negative 45. So this is also acceptable. So from these two, he got 2 marks because the calculation over here is correct. But please be careful next time, Adam, because if the one that you calculated over here, 2 ampere and 1.6 is maybe this 2 ampere has become 3 ampere, maybe it's become 5 ampere because of your maybe careless mistake in calculation, you will not get any answer. You will not get any marks unless if you show me how do you get this value, and I would consider maybe half mark for that. But if you leave it like this, if it's correct, yes, okay, it's you're gonna get marks. But if not, it will vanish like that. So be careful next time. And at the moment, Adam got 4 marks already out of 10. It's 40% from the total marks. And later on, I don't know why Adam tried to do it this way, because from the last one, I think it's totally wrong. But we work on the circuit that Adam simplifies previously. I mean, before coming to this last diagram. So actually, from this parallel connected elements, we have 3 currents. You can combine all those 3 currents to become 1. So I think in general or in total, Adam only got about 40% correct, or 4 out of 10 marks for this question. Okay, we have a look at the full solution for that. I think up until this part, Adam is correct, but the next thing that he needs to do is a bit, I think wrong lah, not a bit, totally wrong. Okay, thank you so much, Adam, for your sharing. And if you look at my solution, okay, I think we already finished up until this one. And as I mentioned earlier, the current over here, if you look at the direction of the current, is very important. So looking at the direction of the current means that IA can be added into IB and also can be added into the other current. And in other words, I would say that we can combine all 3 same direction currents to become I total, or the total current. And the total current is is quite straightforward. You just add those 3 currents. I think this one is very simple, except that you don't know that it can be combined. So that's the problem. Now, for IT, just add IA, IB, and the current you see in the middle over here, which is 4 with angle of 90, or you can also write it as J4. And you get I total and you get 1 marks. And from here, you can also see that we have 3 parallel connected elements, where if you try to use current divider rule, this in order to use current divider rule, you need to have the total resistance, or sorry, total impedance of these three elements. So the next step, or the next solution that you see over here, I try to find what is my Z total. And Z total is given by this equation, 1 over R plus 1 over this, maybe this is for XL and this is for XC. Okay, 1 over JXL plus 1 over JXC. And remember, this formula is equal to 1 over the Z total, or the total impedance. And you need to inverse it back in order for you to get what is the actual value of total impedance. And I know this is also, if you look at the solution, you see that, oh, it's very easy. But still, I give you 2 marks over here. That is because although you see this is very easy, but actually the calculation is quite tedious. But for example, for some student, maybe they try to combine these two first. Maybe I should get the pen over here. Maybe they try to combine 2 elements over here first, and then leave the circuit to become like this. Okay. Right. Maybe some of the students maybe prefer to combine 1 by 1. And maybe for me, I think if you have a good advanced calculator, you can always do the inverse of it. So if you do the inverse of the elements over here, you can straightforward get your Z total. So which methods that you prefer, it's acceptable. So that's why I'm giving 2 marks over here, because this is not as easy as you see over here. Okay, later on, in order to apply current divider rule, basically this is current divider rule. Okay, current divider rule for more than 2 branches should be calculated using this formula. So you have Z total. Okay, if you like to calculate the current over here, means that you need the information of Z total and divided by the value of the impedance, or the maybe resistance also can, impedance or reactance, the value of element over here. You should divide Z total with the value over here and times the current before splitting into 3. Okay, current over here before splitting into 3. Okay, that's why here we use Z total divided by XC times the total current. And again, this is not an easy calculation, because you need to know the formula. Basically, this is some student may be wrong in this part, maybe doing something, I don't know, make mistake at this part. And also the calculation over here is very tedious calculation. So that's why you were giving, I considering 2 marks to calculate this IO. And since if you look at the circuit, since you know what is the current flowing through here, and then your next objective is to find what is the voltage across here, across this element, just multiply the current and also the value of your reactance or impedance or resistance, any the element itself, using Ohm's law to get your final answer. So all this normally will lead into a 10 marks solution. So that's the total, the overall answer of question number 2. Any question? Any questions so far?
All right, sir.
You can understand the solution? Maybe you can try
Yes.
this question and try it in a different way. For example, don't use this kind of what do you call it, to find IO. Don't use this kind of strategy.
Okay,
Maybe
I will try.
maybe you try using for example, okay, this is the capacitor, the current that you would like to current flowing through this capacitor. For example, this is IO, okay, and this element is basically the what do you call it, R in parallel with XL, JXL. Maybe you can also try to use this kind of calculation. And for using current divider rule, using this type of circuit, maybe you should consider this formula. For example, here we have, let's say this is Z1, Z lah, Z. Z, okay, Z. Okay, now to use this kind of strategy, Z should be divided by Z plus negative JXC times I total. So maybe you can try to use this kind of solution. Okay, that's for question number 2. So far, you don't have any question. Maybe later on, if you have question, you can ask directly in the WhatsApp group. Okay, we look at question number 1. Okay, question number 1 is quite interesting because this is the continuation from what we have last week. Last week, remember that we only discussed about node analysis. We didn't spend time to calculate or to have a look at the problem involving mesh analysis. But basically, it is similar from what you've seen in the circuit for mesh analysis as far as mesh analysis is concerned. But in this case, we have an AC sources, and also we do have like calculation involving complex number. Anyway, we proceed with the solution for question number 1. Here it says, considering the current direction of 3 meshes, solve the mesh current I1, I2, and I3 using mesh analysis. Hence, calculate the value of IO. Okay, you need to identify where is your IO. IO is current over here, and it says here that you need to use mesh analysis in order to solve this I1, I2, and I3. All right, according to the circuit, we know that for there are 3 meshes, and we have one mesh which is having a current source which is here, and the meshes have been notated, and this one at the left is I1, at the top is I2 or mesh number 2, and the left one is I3. And if the current direction is given like this, please follow the direction according to the question. Because if you didn't do that, maybe your calculation will be the potential of having a wrong answer is quite high. So basically the direction here is the tips for you guys in order to solve the question given. All right, we will start with the easiest mesh, which is mesh number 2. Here, mesh number 2, without doing any calculation, you can easily get 2 marks over here, but just by defining that mesh for mesh number 2, it is given by I2 or -1 with the angle of 0. Okay, this is not the correct answer for that. Okay. I think there's some mistake in the solution given. But anyway, we try to work out the solution. Okay, for mesh number 2 is over here, but says here is negative. I'm doing something. I'm not presenting the correct solution. Maybe later on I will give you guys the correct solution. But anyway, I will give you the what do you call it, the idea of how to solve this kind of problem. Okay, we cannot use that solution. Maybe I will try to draft another solution and give you guys later on. All right, if you try to solve this circuit, the first thing you need to do is you look at the easiest mesh that you find in the question. The easiest is here, mesh number 3. So you can define mesh 3. Okay, mesh 3, I3 is given by 1 with the angle of 0 degrees. So this should give you marks, at least 1 mark, or if you look at the solution that I have just now, I also can give you 2 marks for this one, because although it just by writing down this without doing any Kirchhoff voltage law or Kirchhoff any equation writing, complex equation writing, just by defining mesh number 3, I3 equals to 1 with angle of 0. But the difficulties here is that you need to really understand that if you have a mesh over here and the current is flowing through the mesh, you need to identify that the current is what being given in the question. So this should be easiest part in this question. All right, and we get into mesh number 1. Okay, mesh number 1. Okay, before we start into mesh number 1, the first thing we need to do is we need to identify the polarity of voltage drop across all the elements inside the mesh. So here we have one over here, voltage drop of 2 ohms. Since the current is flowing in that direction, means that we can label this one as positive, this as negative. And since we go around this way, so we should expect this also in this polarity direction, where we have positive at the top and negative at the bottom. Later on, we should try to work out the KVL around the loop. So KVL around the loop, if you start over here, okay, that would give me, the first one is -8 with the angle of 30 degrees. Okay, plus, and to get what is the voltage drop across here, I need to know what is the value of current over here. Let's say I label this one as IA. IA over here is actually combination of I1 and I2. Why? Because looking at this junction, okay, if I draw back that junction, this is my IA. oops, this is I1 and this bit is I2, where IA is equals to what here is I1 minus I2. So I can say that here is IA times 2. Okay, and plus, okay, go through the loop. If I would like to know what is the voltage drop across here, I need to know what is the current here. Okay, and maybe I label this one as IB. Okay, forget about IO first, just label it as IB first. And to know what is IB, I would focus on this junction. If you look at this junction, that junction, I have I1 is flowing in that direction. I have I3 in that direction. Okay, since I3 is flowing that way, I1 is flowing in that direction, and IB is here. So that is why the current direction is very important, because we need to determine the direction of the current and what is the exact equation of the current that we need to find. So here IB is equals to I1. This is not I2. Did I say I2 just now? I think I said I1. It is I1. IB is equals to what? I1 let's see, I need to get back into Kirchhoff current law. Sum of I in equals to sum of I out, where I in is IB, I out is, okay, I1 plus, okay, this is very something that is very new for you guys. Okay, from the direction, if you don't know what is IB, you always get back into this kind of definition, the definition of current Kirchhoff law. Sum of I in equals to sum of I out. And in this case, IB is I1 plus I3. So because it's not always I1 minus something or I2 minus the other I, not always like that. You need to really identify or really examine what is the correct equation for that particular current. And here IB should be multiplied with negative G5. Okay. Now we compete with mesh number 1, and for mesh number 1, what you need to do is you need to rewrite this equation and substitute whatever definition of current that you have in this equation. And at the end, I think if you substitute IA as I1 minus IB, and IB is, IA is I1 minus I2, IB is I1 plus I3, and also substitute I3 equals to 1 with the angle of 0, you will end up with only two unknown variable, which is I1 and I2. Okay, next we move on into mesh number 3. mesh number 3, mesh number 2, the last one. Mesh number 2. Okay, this is, okay, if you look at my solution over here, I give you the idea of how to develop the equation. And later on, you need to identify, or you need to solve it, the exact solution of it. You need to do the math. All right, for mesh number 2, okay, mesh number 2, maybe I try to change the color over here, change it into blue. Okay. Mesh number 2, we are considering these 4 elements: 2 ohm, negative J5, J2, and also J1. And looking at the direction of the current, it should be the way we notate the polarity should be in that direction for negative J5, in that direction, or in this kind of polarity arrangement for J2. Here is for J1, and the other one is for the 2 ohm resistor. Right, let's move on. I think I need to write the equation down here because we have 4 elements. Maybe here is more suitable. Okay, if I start, okay, my loop from here. Okay, the first one is I2 times G5, negative G5. Next one is plus I2 times J2. Okay. The next one is, okay, due to this current, in order for me to get the voltage over here, let's say it is not, let's say, it is actually not a definite I2. This may be the combination of 2 currents. Let's say I put it as IA, IB, and this one is IC, okay, plus IC times J10, sorry, J1. Oh, my J is not that good. I erase this first. Okay, this is J1. Okay, the last one is plus. Okay, before we get into this one, first we try to solve this IC first. How do I know what is the equation for IC? So from this junction, okay, see the junction is like this, and the current that I want is here, IC. I know this one is I3, and this one is I2. I2. So here IC can be written as what? I3, sorry, I2. Is it I2? Is it? Yeah, I2 plus I3. Okay. Why here it is plus? Because if you return back to the definition of Kirchhoff current law, or the definition of I in equals to sum of I out. Okay. I out over here is IC, and I in we have 2 currents, which is I2 and also I1, sorry, I3. And that's why we have IC equals to I2 plus I3. Okay, that's for IC. And here, the next one is the voltage drop across this 2 ohm resistor. If I have a voltage drop across here, I should first know what is the current over here. The current, we don't know the exact current, and basically the current is the combination of two currents, and we label it as ID, and we can put it as ID times 2 ohms, okay, equals to 0 because we return back to the original point that we started before this. Now, the problem here is ID. What is ID? And we know that ID is a combination, it's not definite I2 or it's not definite I1, and also it is not definite I3. So we need to find what is the equation for ID, the real equation of ID. And the way I know, the way I get the equation of ID is by looking at this point. Okay. Why I'm not looking this point? Because this point is quite cramped. You know that we have a current over here, which is IB. IB also is a combination of a current. And current over here is IC. Also, it is a combination of another current. And maybe the best way is to find where is the junction that definitely tell us the exact current or a certain current that flowing through there, not the combination of two currents or maybe more. Okay, luckily, at this junction, we already examine what is the current relationship of this junction. And we know that earlier, IA, if I have a current direction is from that current is labeled in that direction, means that IA is equals to I2, I1 minus I2. If I would like to have a current which is in the opposite direction, and here is maybe ID, it is basically the inverse of what we have for IA. So here is I negative IA, or we can say this is I2 minus I1. And again, for mesh number 2, maybe I should erase this one. I should write it here. Mesh 2. Okay. For mesh number 2, if you substitute all the current definition, for example, we have IC here given by I2 plus I3. And for ID here, we have I2 minus I1. And if you substitute all the equation and try to write it back, you will end up with also two unknown variables, which is I1 and I2. And solving that two unknown variable, I1 and I2, lastly, you will get what is your IO. And from this circuit, you see that IO is basically, maybe I put another color. Maybe now we put it as green. Okay. IO is basically the same as IB here. You know that the direction is the same, so we can say IO is equals to IB. And if you solve these two meshes, if you solve this mesh and also this mesh, okay, you will get I1 and I2 and use the information to get your IO. Here, you only need to know what is your I1 and plus it with I3 in order to get what is the value of the IO. Okay, and basically you always need to solve all the current, because inside the original question asks us about I1, I2, and I3. And finally, for IO. So once you solve this one, IO is quite straightforward based on the circuit or based on the direction given in the circuit. All right, any questions so far?
No, sir.
Okay, can you follow the solution? Can you follow? Do you have any question with the solution? This is not the complete solution. You still need to work out the the calculation, the simultaneous equation. You have two unknown variables. You need to solve it, and later on, you will get your final answer. But in general, this is how we solve mesh analysis, particularly for this question or this problem. And if you have a DC circuit, you can also use this kind of strategy. The first one is that you need to label your polarity, voltage drop polarity, and later on work out the KVL around the loop and write your voltage drop in terms of currents. Okay, if you don't have any problem here, then we should proceed to the last question, and we have another half an hour to explain. I think this one is quite straightforward. We try to use superposition theorem to solve it. Okay, Adam asked about, can I send the answer in WhatsApp group? Why? I always send the answer in e-learning, Adam. Please get into e-learning and download the answer. Yes, I will send you the answer. But at the moment, the answer that I have over here, as you look just now, is I think wrong. Maybe it's not translating not aligned with the question given. So I would like to revise back my solution and try to give you the correct solution later on. But before I give you the solution, please work out the calculation first, because you also need to try it before you get the answer. All right, now we proceed to the last question. It's question number 3, asking about Ix using superposition theorem. Let's see, maybe I think this one should be no problem. Right, where is the answer? Okay, here. Can you see both file? Yeah. All right.
Yes, sir.
Remember that for superposition theorem, okay, if the sources over here is given in sinusoid form, you need to convert the sinusoid form into its phasor form, or you need to write back your sources in phasor domain. Luckily, in this question, it is presented in phasor form, so you don't need to do anything about converting from time into a phasor domain. The problem here is that you need to analyze the circuit using superposition, and also you are very lucky in this question because the elements over here for inductor and also for the capacitor also being given in its reactance value. So we can go ahead with the analysis using superposition theorem. And if you remember that superposition theorem, we only, if you have two sources, means that you need to calculate that particular parameter. For example, in this case, Ix, you need to calculate Ix 2 times, okay, because we have 2 sources. If you have 3 sources, means that you need to calculate Ix 3 times and combine those Ix to get your final value of Ix. And in this question, we have 2 sources. The first one is we have is current source, and the next one is the voltage source. And you also need to remember that in superposition theorem, we only consider one source active at a time. So it means that the other sources, okay, except for the one that you consider as active source, is considered as 0 value. Or for example, for voltage here, voltage source, we should treat it as, okay, this is voltage source, we should treat it as short circuit. And for current source, later on, maybe current source, we should treat it as an open circuit. Okay, this is what happened in the solution. If you look at the solution, okay, the first one I consider 10 this current source as my active source, 10 with the angle of 0 degree ampere. So this is the active source that I'm considering. Now I try to change back into maybe red this time. All right. And if you look at the voltage source over here, I treat it as a short circuit, V source. And the first thing I did was I defined what is my elements first at each branch. The first one we have Z3, where Z3 is the combination of resistor, and also this is R, and also this is minus JXC, or our capacitor. Looking at the question back, okay, since okay, yeah, correct. I redraw the circuit. Maybe I should put it this way. Okay. If you look at the solution that I have over here, although okay, nothing new. All right, it's okay. I messed up my my head is messed up. I thought these two I combined together. No, I just combined these two together. Okay. Consider it as Z1. Right? This is my Z1, and Z2 is this element, or this J4, and Z3 is this resistor. And this one I put it as a short circuit, and I just redraw it based on this circuit given in question. Okay, later on, what you need to do is you need to simplify the circuit for your own convenience. That is very important. Not important to me because I only looking at your answer, but it's for your own convenience, and you try to explain to your examiner on what you're trying to do. So here, from this diagram, I change it, or I simplify it into this diagram. And to simplify into this diagram, you need practice. Here, looking at this point, okay, that one is over here, is connected to Z3, yeah, connected to Z3, and also connected to the current over here. Current, and the direction should be pointing upwards. So you should simplify this circuit and getting into this kind of circuit arrangement. Again, this is for your own convenience. And to calculate the current over here, I prefer the fastest way, because I can make use of current divider rule. Here I use current divider rule that using this equation for Ix, I need to find what is my Z total, divide by the Z1 over here times the current before it's split into 3 branches. So this is the current. Maybe I label this one as I total. So the thing that I need to find is my Z total, and my Z total, again, this is connected in parallel. So I use this kind of calculation where I use 1 over Z1 plus 1 over Z2 plus 1 over Z3 and inverse it back. Okay, this is inverse. So I inverse to get my correct answer, and maybe I forgot to put it this one as ohm. And finally, I can make use this value, put it into a current divider rule, and get my final answer of Ix. And this is my first Ix, or I label it as Ix prime. That is for that is assuming that current source 10 with the angle of 0 degrees active. And what you need to do next is you need to calculate Ix based on the other source. So the other source we are considering here is the voltage source with value of 50 with the angle of 30 degrees volt. Here, I change it into a rectangular value for the ease of my calculation. Maybe, I don't know what is your preference, but if you convert this one, it's no harm, because maybe you need to calculate using this kind of form later on. Okay, again, the strategy is the same. For current source over here, I put it as open circuit, and for voltage source, I make it as active source. Only one source active at a time. And the circuit, I don't have to further simplify it, because I think this is the from this kind of circuit arrangement, I can guess, or I can easily know what is my the strategy or the target value that I'm looking for. So the thing is that the strategy I use here is by using current divider rule. If you see here, I use current divider rule, and to use current divider rule, I need to find what is my total current first. Where is my total current? My total current is over here, where the current coming from the supply. And basically, I total, if I draw, is over here. This is the current presented here as well. And it is because this the part at the top over here is open circuit. In other words, I would say that this circuit can be also drawn like this. I have voltage elements over here and another 2 elements here. And I try to find what is the current flowing through here and label it as my total current. And to find what is the total current over here, I need to know what is the Z total, or total impedance inside the circuit. And the total impedance, if you look here at the circuit, we have two elements, Z1 and Z2 are in parallel, and we have a series connection between these two parallel elements with this Z3. So this is what happened, or this is how I calculate my Z total. And again, my Z1, Z2, and Z3 basically kebetulan, it's fortunate that the Z1 is the same from what you have in the first solution. But I would really suggest or advise you guys to define back your what is your Z1, what is your Z2, what is your the impedance value, because sometimes maybe it's a bit different because we have open circuit part over there, maybe short circuit part here and there. So it's a good idea that you define back what is the exact value of your impedance. Luckily, in this question, it's the same what we found in our first solution. But maybe if you are if question, maybe the value of your impedance maybe slightly different. All right. Now we know what is our Z total, and solve this one for parallel connected. I also use inverse value of Z1 over Z 1 over Z1 plus 1 over Z2, and then I inverse it, and later on combine with my Z3 because it is connected in series. And once I got my Z total or total impedance, I try to find my total current. Basically, total current coming from V divided by Z total. And my V is 50 with the angle of 30. And finally, I will get my I total as this value. Again, I'm not focusing on the value because maybe here I use 4 decimal points. Some of you guys maybe consider 3 or 2 or maybe 1. Please put decimal over there. But I'm not focusing on that one. I'm focusing on your strategy. How do you solve it? How do you tell your examiner on how to solve the question? So that is more important in my perspective. So here, after I found Z total and I've calculated I total, I can use current divider rule. And current divider rule here, using these 2 branches. Okay, if I would like to calculate what is the current over here, if I try to calculate the current here, okay, Ix. Okay, this is my Z2, Z1. Okay, I will use this equation, Z2 divided by Z1 plus Z2 times I total, because this is in series, means that the current over here also I total. So the current before it splits. Remember, the current before it splits, because some student maybe, okay, definitely I total, definitely I total. What happened if we have another branch? So that kind of definition is very important. Before it splits, this current. Okay, Ix double prime can be calculated using this equation, and at the end, you should combine your Ix as Ix equals to Ix prime times Ix double prime, the one that you calculated earlier, this one, and also the one when 50 with the angle of 30 degrees voltage source active. So that is the solution for question number 3. And question number 3 also is quite, I think, is quite straightforward. And also, it's a typical question asked in your assessment, whether it is in test 2 or it is in final exam. So you need to really be alert of how to solve a circuit using superposition theorem, because you only consider one source at a time. And if you have more, if you have 3 sources, means that you need to do 3 times calculation for that particular element that you want to find. Any questions so far? Doctor, I don't understand why ID equals to negative IA. Okay, we recall back the Kifu Wang asking about why ID equals to negative IA. If you look at the direction of the current, here, okay, maybe I put it bigger over here. IA is in that direction. And ID, we define it to be in the opposite direction. That's why we put it as ID equals to negative IA. This is to make, we don't have to do the calculation again, because we know that IA and ID direction is basically in an opposite direction. So that's why we put it at ID equals to negative IA. Is that clear, Wang? All right. Any question from the floor? Have any question regarding any question in this tutorial? Okay, can you follow the solution? Can you follow it? Only the same person. Only the same person respond to me. But actually, I don't mind. I just want a response from you guys, knowing that you are in good shape or in good understanding. So if you didn't respond, means that it leaves me with a question mark whether is my mic is on or whether what I'm presenting here is available for you guys. I don't know, maybe a lot of question marks over there. If you respond, means that, okay, it's been delivered. All right, thank you so much.
Thank you, Doctor. Doctor, there's a question in the messages from Q4.
Question? Question number?
From Kif Wang asked in the messages.
I think I've answered this one. I already answered the question here. I don't understand about why ID equals to negative IA. Did I answer one question? He responded, yes. Okay, over here.
Okay, sir, my mistake.
Okay. Never mind. It's okay. Any question?
Sir?
Yeah.
If we don't follow the given direction of current in the question, for example, in question 1.
Question 1, okay.
But still we get the correct answer, then will we get the full marks?
Yes, of course. But remember that I3, for example, if you define your I3 in this direction, yeah, for example.
Yeah.
Okay. And at the end, you get your I3 by solving the, no, your I3 should be written as, in this question, should be written as negative 1 with the angle of 0. You should define, when you try to substitute I3, you should substitute I3 using this definition, because it is in the opposite direction with the current source that we found over here. And towards the end, okay, when try to answer back what is I3, okay, I3, I would consider I3 is equal to 1 with the angle of 0 degrees, because according to the question, I3 is in the direction labeled here, and the direction that you have over here is the opposite direction. So you can say that this is basically I3 prime, that you define it by yourself. According to the question definition, based on the direction of the current, I3 should be 1 with the angle of 0. It's a positive value. Am I clear?
Yes, sir. Understood.
Okay. But if you get the answer correct and everything is good, you should get full mark for that. But be careful when you try to change the direction, and it also will affect your calculation later on, because the one that you try to substitute over here highly related to the direction of the current defined in the question. Just be careful with the direction, and if you got the correct answer, that should be okay.
Okay, sir.
All right, any question?
No, doctor, thank you.
So far, okay. All right, I think we are towards the end of our session.
Yes, please.
Okay. As usual, I would like to take a look at you guys. Please turn on your camera. We try to snapshot for the attendance. And I hope you can get something from today's tutorial, because this the question that I show you or give you guys today, maybe yesterday, the last tutorial last week, is a typical question available, or typical question in your assessment. So it's very important that you really understand about the solution, and hopefully you can do it by yourself later on. And I really apologize for the solution that I have for question number 1, because I think that is not, aligned with the question that I gave you in the tutorial. But basically, we already discussed the solution, and hopefully you try to work out based on the strategy that I show on the circuit analysis. Anyway, for next class, we will meet again on Tuesday, and we try to discuss on Thevenin and Norton theorem for AC circuit analysis. It's more complicated from what you've seen previously. So stay tuned lah next week. All right. Anyway, thank you so much for your attention. Don't forget to fill out the attendance form. For those who still didn't fill out the attendance form, I post the link again here. Please have a look at the link and fill out the attendance form. With that, I think that's all for today. Thank you so much for your attention, and hope to see you again next week on Tuesday, 9 a.m. Thank you so much. Assalamualaikum.
Waalaikumsalam, Doctor. Happy New Year, Doctor.
Excellent, sir.
Stay safe.
Salam, doctor. Have a good day, sir, doctor.
Okay.